In this video, we're going to talk about proving lines are parallel. If two lines are cut by a transversal so that the corresponding angles are congruent, the alternate interior angles are congruent, the alternate exterior angles are congruent, the consecutive interior angles are supplementary, if any of those things occurs, then the lines are parallel. All you need is one of those four things to occur. For example, let's say I give you this diagram. I'm going to label this first line L, the second line M. And I'm going to say they're cut by transversal T. And let's say we have angles 1 and 2 here. And let's say I give you this information. I give you that angle 1 is congruent to angle 2. It's given information. Well, those are corresponding angles. And if we go back up to the conditions listed up above, we said that if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So as long as angle 1 is congruent to angle 2, we can say line L is parallel to line M, because corresponding angles are congruent. And that's all we need to prove those lines are parallel. Now let's say I give you another diagram. I'm going to say this is line P, Q, and transversal T. I'm going to give you these two angles, angle 3 and 4, and I'm going to tell you that angle 3 is congruent to angle 4. Now, are lines P and Q parallel? Yes, because angle 3 is congruent to angle 4, and those are alternate interior angles. We can say that lines P and Q are parallel. So we're going to say P is parallel to Q because alternate interior angles are congruent. All right, and that goes along with one of the conditions listed above. Let's go to the next page. Let's say I have these lines, K and G, transversal T, and I label angles 5 and 6, and I tell you that angle 5 is congruent to angle 6. Can I show that K is parallel to G? Absolutely, K is parallel to G because what kind of angles are angles 5 and 6? Those are alternate exterior angles. So we're going to say K is parallel to G because alternate exterior angles are congruent. So we're illustrating each one of the properties listed. Now, in this next picture, I'm going to have lines C and D, transversal T, and here are angles 7 and 8. And I'm going to give you this information that the measure of angle 7 plus the measure of angle 8 equals 180 degrees. And that is enough to show that lines C and D must be parallel. We're going to say C must be parallel to D because angles 7 and 8 are consecutive interior angles, and if consecutive interior angles are supplementary, then the lines are parallel. So we're going to say because consecutive interior angles are supplementary. Now, let's take a look at this next bit of information here. It says find the value of x that would make these lines parallel. Well, these are consecutive interior angles, and we know consecutive interior angles must be supplementary for lines to be parallel. So that would mean 3x and x must be supplementary. So if they're supplementary, they would have to add to equal 180 degrees. So that's given us an equation to solve. So let's combine our like terms. 3x plus x is 4x, which is equal to 180. We'll divide each side by 4, so x would have to be 45 degrees. Next, in this diagram, what would the value of x have to be for these lines to be parallel? Well, these are alternate exterior angles, and we know that in order for lines to be parallel, alternate exterior angles must be congruent. So in other words, 60 minus x would have to be equal to x. So to solve this, we'll have to get all of the x's on the same side, so we'll add x to each side, and we end up with 60 equal to 2x. Dividing each side by 2, we end up with x equal to 30 degrees. That is it for today. Thank you very much for joining me.